lecture today. Of course, today the focus is going to be on probability distributions of continuous random variable. Before now, you've been introduced to random variable, and of course, random variable can either be discrete or continuous. Of course, the previous weeks we've actually committed that to discrete random variable and their probability distributions. And of course, we're starting a new chapter today. We're going to be focusing on continuous random variable and also with their probability distribution. So in the outline, of course, you'll be able to understand properties of continuous probability distributions. In a stochastic environment, if we actually want to analyze or depict reality, we normally use a random variable to define events. And of course, we need to be able to identify what type of random variable am I talking about. So is it discrete or continuous? Okay, so if it is continuous random variable, then we actually going to look at the properties of that. We actually need to do that. So by continuous random variable, of course, I'm referring to situation where we have where the occurrence of event or random variable can occur in a given interval. Okay, and at times we normally said it takes what I call a continuous random variable takes takes an something that I'm actually going to say uncountably number of infinite outcomes. Okay, it takes an uncountably number of infinite outcome. Okay, and of course, if I have a random variable s, if it is continuous or in nature, so I'm actually going to say there exists a probability function, just like what I walked you through the other time. When for discrete random variable, there will be a corresponding probability function that we call probability mass function. But for continuous random variable, we're going to call that probability density function. Okay, probability, okay, density function. Okay, the acronym is PDF. Okay, while that of the discrete is PMF. So as you can see, PDF. Okay, now because if I want to figure out the probability of of an event or occurring within an interval or A and B, then I need to be able to identify the corresponding function, which I call the PDF, and that very function, all what I just need is I'm going to perform an antiderivative, on the function that we call integration over the range. Okay, so that is what we mean. So whenever for instance, in environmental study, I actually want to know the amount of pollutants, in a environment within a certain period. So I need to be able to identify what is the corresponding, the probability of function. It could be in engineering where you talk about signal processing. In signal processing where you actually want to extract a noise, from the signal. We're able to do that with a continuous random variable. So if you're able to extract noise, of course, that will improve the quality of the signal that you're actually going to be getting, because we live in a world where data are contaminated. Okay, so if you take a look at what I have here now, Okay, this is the density function. Take a look at this guy. That's a density function. Okay, we are seeking to find a probability of the occurrence of a random variable between an interval we have identified. And when you take a look at what I have here, we f indicate I have a function. I need a function, and I'm actually going to be mapping from a real number, okay, to 0 to infinity, because the probability that I'm going to get at the end of the day must be non-negative. That is what it means, okay? It has to be 0 or more than 0. And that's why you see this is close at 0. Does that make sense? Okay, now that's what we have. And if I want to do that, then I must be ready. I told you the other time, I'm going to find the probability of a x. X could be income level, it could be income. X could be a change in demand and supply. It could be whatever, okay? And the probability that the S, and if S is continuous, and I want to see the probability that is going to lie between A and B, then I must be ready to perform an antiderivative on the corresponding function for that over the range, okay? Now, I'm gonna come with some definition axioms. Number one, if you take a look at here, if you look at this guy now, it's trying to say the PDF, which is a probability function for continuous random variable, has to be non-negative. Okay, this guy means for every x lies in real number. For every s in real number, okay, this has to be, that non-negativity has to be defined. And another crucial property here is, if f of s is a probability density function, like if it is a valid one, okay, when I integrate, the function over the state space must give me 1. Do you know the corresponding, like the one in the discrete? In the discrete, we do this, right? We do this. Sum of that must be equal to 1, okay, over the state space, okay? But in continuous, take a look at this. Do you see the difference? The two of them are saying the same thing. Okay? The two of them are saying the same thing. Now, like I said, I can find the probability of x lie between A and B. Where A is the lower bound and B is the upper bound. Okay? And this guy means for every A, B lies in real number, where A less or equal to B. Does that make sense? Okay? Now, if you understand that now, then I'm going to move to more general. Okay, take a look at this. We don't talk about that when it comes to continuous random variable. We don't, I normally use probability. I normally use this guy in discrete, right? Because in discrete, I can do what is the probability of s equal to 5. But in continuous, I can do that. Does that make sense? The probability that s equal to an exact value, and if s is continuous or random variable, is 0. Because there's so many values in the interval. Okay? So please take note of that. That is what led to the number 2 here. Okay? The probability of s equal to A. Okay? You see that? Equal to that. Okay, look at that. That's defined. And another thing I needed to pay attention to. Oh my God. Look at this. This number 3 is only peculiar to continuous random variable. It is not true for discrete. In a continuous random variable, there's no difference between this. Please pay attention. Whether S lies between A and B, inclusive, or S, they take a look at this or that. They all mean the same when S is a continuous random variable. Okay? Please take note. Okay. So if I want to find the probability associated, okay, where a random variable S lies in A, then what that guy is telling me, I must be ready to do an antiderivative. Okay? That's what he's telling me now. Okay, now I want to move right now. Please, I need you to pay attention now. Take a look at this guy. Take a look at this guy. Okay, if I've used all the entire state space, okay, that should give me 1 when I perform an antiderivative on that. That's what it means. Okay, negative infinity to that. Now you will see it in the picture. The area is everything is shaded. Everything is shaded. Okay, but let me move to the second picture. Oh my God! It is not, the entire area is not shaded. Do you see the shaded part? Now, when you take a look at the shaded part, okay, now the area now, you want to focus on this area now, okay. I want to tell you, the moment you are done with this, your answer is going to be less than 1, because when you use the entire area, the total area under a curve must be equal to 1. If you are truncating it, like here you are kind of truncating that, you didn't use the entire area. Is there any question at this time? Any question? Now, we have another possibility. At times, we may be interested in this guy. Okay, you take a look at this. I'm interested in a region greater than B. Let me tell you this. Whether I'm gonna write something now. As far as continuous random variable is concerned, they are the same. Now take a look at this. Take a look at this. The probability of S greater than B is the same as this for continuous. Okay, here now. I'm really interested in this part. If I'm interested in that part, okay. If I'm interested in that part, what I'm actually gonna do, my lower band is going to be B, because I'm starting from here, and that goes all the way to infinity. You can see that. Okay, if you want to find your probability correctly, when you are dealing with continuous random variable, you need to first identify correctly your state space. The moment you don't identify your state space correctly, that's going to be an issue. Okay, so I'm going to show you another one now. Take a look at this guy here. Okay, this is to the left. I'm going all the way. You see to the left? Okay, which is going to be less or equal to A. So similarly, the probability, when you're talking about continuous, the probability of S less than A is the same as S less or equal to A. Okay, for continuous. That is not true for discrete.